Hey there again. So without further ado, let me present the agenda of today's webinar. We'll start with a comprehensive overview of the REST API. We'll have a look at the documentation and we'll go through the process of making requests. Then we will touch upon the reporting automation with Python. I will share the scripts with you and we will run a few of them. The last part will be about the actual use cases for the REST API, where I will tell you about how our customers use it and what kinds of problems it helps to solve. So before we move on to the main part of the webinar, let me say a few words about me and our company. So uh, my name is Dmitry. I'm a product analyst at Stillsoft, which is the Atlassian Silver Solution Partner and the Platinum top vendor at the Atlassian Marketplace. Our products are used by more than 4,000 customers worldwide every day, and with more than 25 apps on the marketplace, we try to make the working process simpler and more productive. So we create apps for Confluence, Jira, and Bitbucket, and our top-selling apps are data center approved and available in hosted and cloud versions. I'm also part of the Awesome Graphs for Bitbucket team, and our app helps engineering leaders evaluate teams' performance, track process improvements, and deliver products faster. Over the years, our app has evolved, and in version 5.2.0, we've added the capability to interact with the data provided by our app via the REST API, which is the main topic of today's webinar. So, the REST API provides the data on global project repository levels as well as the data of particular user. Our solution allows you to retrieve data faster while decreasing the load on the instance compared to Bitbucket's REST API. Another point is that using our resources, it's much easier to get the data for a particular period of time. It also allows us to get the number of lines of code added and deleted for each level and get the global statistics. In addition to all the things described, it gives the capability to export all the commit and pull request data to CSV, which simplifies the reporting process. With the Awesome Graphs REST API, you can integrate with analytic platforms and custom solutions to extend their capabilities with live access to data provided by Awesome Graphs. You can aggregate, sort, and filter the data in Excel, Tableau, Google Spreadsheets, and other tools. You can build custom graphs and create live dashboards for real-time monitoring. And also you can merge data from Bitbucket, Jira, and other sources to enable end-to-end visibility reports for management. So now we are moving on to the actual overview of the API. I'm going to guide you through the whole process of working with it. First, I'll show you the documentation. We'll show how it's organized and how to work with it. Then we will make a few requests. We'll try out all the available parameters and all the ways to get the necessary data. Okay, now let's look at the docs. Actually, there are two variants of them, so I'll show you both. The first one is available for everyone and is located on our documentation website, docs.stillsoft.com. The other one is in-app documentation, which is available only to the Awesome Graphs users. So here are some glimpses of it. Let's look more closely at the documentation website. Here, all the information is presented as a single page to make navigation and finding the necessary resource easier. For the same reason, we've got the table of contents at the top right. At the very beginning of the page, you see the overview part that gives you the information about the URL structure and shows the example of a request and parameters usage. The main part of the document is divided into two parts, one for commits resources and the other one for pull request resources. Each of them is further divided into four levels: global, project, repository, and user. You can see that each level contains three resources. The one to retrieve list of commits or pull requests on the chosen level, the one with statistics, and one more to export data to CSV. There is one exception, as the commits repository level has four resources. The thing is that in version 5.6.0, we've added a new resource to retrieve data for a single commit identified by its ID. So here it is. Each resource has all the parameters described, and we've also included curl or CURL request examples and sample responses, so you'll know what you'll get and how to get it. Now let's look at the in-app documentation. So you can access it right from your Bitbucket instance. Click on the People menu in the header and choose All Users. Now you are on the People page. Click the Export button and then REST API. And that's it. You can see that the in-app docs are structured in a similar way, but kind of mirrored. You have a navigation bar to the left, the resource description in the center, and the response examples to the right. Above the response samples, you can get an automatically generated URL, which you can just copy and paste, no modifications needed. So let's get right into it and make a few requests. As I said, I'm going to guide you all the way through the process of making a request, and will show you how to use the available parameters. We'll use the Postman app for the main part of the demonstration, but I also show how to make curl requests and how to get the data right from the address bar in your browser when it's convenient. We'll start with the curl request. I'll show you just one example and we'll explain how it all works. So in the first place, you need to open your command line. Here I'm using the command prompt as I'm on Windows. Now you can go to the documentation website and copy a request example from it and then edit it accordingly. So let's look at this example. In the first place, we state that it's going to be the curl command. With the dash and capital X, we specify a custom request method to use when communicating with the HTTP server, which is now get. And after -u, we specify the username and password to use for server authentication. And then comes the URL in brackets. So after you've copied and edited the request example, paste it to the command line and press enter. So here we are. You see, while it does return all the requested data, it looks really messy and hard to read. But you can make it look prettier if you have Python on your machine. So let's copy our request once again, but this time we'll write the following into the command line. You start with vertical bar, then you write python -m json.tool. Press enter, and now it's formatted as a JSON file, which is much easier to read. Now we are going to continue working with requests in Postman, as it suits better for the demonstration purposes. Let's have a look at it. Postman has quite a lot to offer, but the main reason why I'm using it today is that it allows me to create and save collections of requests to simplify the authorization process and reuse the requests. As you can see, I have already created a collection for this demonstration, but I'll still show you the whole process from the start. So we click on New, then Collection, give it a name. Here you can write the description of this collection, and you need to set the authorization to basic auth, where you pass your username and password so they can be inherited by all the requests in this collection. Then you click on Create. I'm not going to do that because I already have one. So now you can add a request. Once again, click on New, Request. Let's make one that returns the list of commits from the whole Bitbucket instance. Let's call it Global Commits. And save it to the current collection. Here, you need to enter the request URL, which you can get from the docs. go to the global level, click on commit, and copy the automatically generated URL. Then paste it to Postman, click send, and here it is, you've got the list of commits. Let's try out a few of the available query parameters. You can find them all listed in the resource description, so here it is. Um, all of our resources have the since date and until date parameters that allow filtering the data by the period of time. So let me show you how it works. In Postman, you have the key, which is the name of the parameter, and you state the value, which is in our case the year, the month, and the day. The same works for until date parameter. The year, the month, and the day. Then you click send, and here's the list of commits made during the stated period. Now, let's use a few more parameters. For example, order. It states the order to return the commits in. So let's set it to oldest to return the oldest commits first. Also, we can use the limit parameter, which states how many results to return per page. By default, it's set to 25, but you can increase it to a maximum of 1,000. But for our example, let's set it to 100. Click send. And here we've got the list of 100 commits. Okay, so there is also the start parameter, which states which item to start the list with. So as we've just got 100 items, we can set it to 101 to continue the list. Click send, and you see that it continues. So here we've got the whole list of commits, but if you just want to get the number of commits, you can use one of the statistics resources described in the documentation. So go to commit statistics, and here you can copy it. As you can see, it's almost the same as the original one, but here it has slash and statistics. I'm going to use the one I already created. So click send. And for the commit resources, the statistics includes lines of code, added and deleted, and the number of commits. Now let me demonstrate one more example now with pull requests. So as you can see, it already has since date and until date stated, but here's the thing. For pull requests, you can also choose what date is used for filtering with the date type parameter. So if we set it to updated, it will only return the pull requests that were updated during the period. By default, it's set to created. So click, and here's the list of the pull requests updated during this period. Another pull request specific parameter is state, which filters the response by the pull request's state. So if we further modify our request and set it to open, it will return only open pull requests that were updated during the period. So now you can see that this open value is set to true. Once again, you can use a statistics resource to get the number of pull requests. In addition to the overall number of pull requests, you also see the number of pull requests grouped by their state. So here it is. As I promised, I will show when it may be more convenient to make a request right from your address bar. Actually, you can make all of the requests this way, but the results might be hard to read, similar to what we saw in the curl example. So export to CSV resources are good candidates to run from the address bar, are as it is the easiest way to generate a report from the request. So let's get one. You can copy it now and put it into your address bar. Press enter. And you see that the file is automatically generated and saved to my downloads folder. If we open it, we'll see that it contains the list of commits with the details such as created date, author's email and username, repository name, project name, commit hash, whether it's a merge commit or not, lines of code added and deleted. You can learn more about exporting to CSV from the documentation website. And for those watching it live, the link will be in the notification on the screen. And if you are watching the recording, you'll find all the links in the description. Okay. So while these resources definitely make the reporting easier, you may want to transform the data somehow. And this is what we're going to talk about in the next section. Even though exporting to CSV and automatically generated files are quite usable already, you're still limited by the structure of the generated file. In this section, I will show you how you can group and filter the data from the REST API and how to automate this process with the Python scripts. So I have created a repository with the scripts that you can try out right now. You'll see the link in the notification or in the description below. So here we've got a bunch of scripts that group, filter, and aggregate the data on different levels and by different criteria. If you scroll down a bit, you can see the description of each script, the requirements, and an example command to run the scripts from the command line. So let's clone this repository, copy the cloning link, and put it into your command line. Press enter. And now let's change our directory so we can run a few of them. I'm using Python version 3.8, and you can check yours by writing Python --version. So let's start with a simple script that shows the number of commits per repository. We have one in our repo, and it's called commits per repo. So let's look at the requirements. This one requires request, CSV, and sys modules, and you need to pass 3 arguments, the URL of your Bitbucket, login, and password. I already have everything it needs, so I'll just run it. Paste it to your command line and press enter. If you're interested in what is inside the scripts and how they work, we can look through them in the Q&A section, but in a few words, this one gets the list of all projects, then the list of all repositories in those projects, and then counts the commits for each one using our REST API requests. And we are done. Let's look at the file that was created in the same folder. Click on it. So the resulting file has 3 columns: project key, repo slug, and number of commits. Now let's run another one that generates a report with global commit statistics during the specified period. Once again, look at the requirements, check if you have everything, and run the script similarly, but now pass 5 arguments: host, login, password, since date, and end date. Paste it to the command line and run it. Okay, done. And here's what we get as a result. Okay, that's it. You can run the rest of the scripts in a similar way. You can mode and change the scripts any way you like. And also, if you have an idea of the results you'd like to get, tell me here or in the comments or write in email, and I'll try to make one for you. As a bonus here, I want to say that it is possible to run this or any other scripts regularly on a schedule. If you are on Windows, you can use the task scheduler. It looks like this. And for Linux and macOS users, there is a Chrome tab that allows that. I'll share the links to the videos showing how they work, and I hope that would be useful for you. Now, coming back to the slides. Now we move on to the last part, the use cases. These were brought by our users who were kind to share their experience and their feedback with us. And the first one, and one of the most popular ones, is integrations with BI tools, analytics platforms, and custom solutions. So all the resources that I showed and described previously, and particularly Expert to CSV, can be used to integrate the data provided by Awesome Graphs into the system of your choice. And here's just one example of a dashboard built in Tableau based on this data. Most of the modern systems support importing data directly from the REST API using JSON as a communication format. But even if the tool of your choice doesn't support this kind of integration out of the box, you can still use CSV as a means of transferring data, as it's accepted by the prevailing majority of tools. So apart from BI tools, there is one more integration popular among our users. That is integration with Confluence. The purpose of this is to share the engineering data with business users and stakeholders. And I'm going to show you an example of a chart built within Confluence with the help of one of our apps, Table Filter and Charts. It's packed with features, so you should definitely check it out. So this example, the pull requests Gantt chart was built with the help of this app. It's actually built with the help of one macro, table from CSV, and based on data from Awesome Graphs. But you are not limited to just one graph. Using it, you can build fully fledged dashboards for different purposes. Actually, we had a series of articles on how to build a dashboard for project management, so I'll share the links to these articles with you, and we'll also give you the link to the guides on how to build graphs and charts in Confluence in case you'd like to see more examples. So, other notable mentions among the use cases are buying a static code analysis tool. So static code analysis tools are used by development teams to ensure proper coding and compliance standards and help the teams successfully meet the release deadlines. When it comes to actually purchasing one, you need to choose a suitable license for your particular case. And usually the licenses are priced per instance per year and based on the number of lines of code. So here's where our app comes handy, as it provides this kind of information. You can use our statistics endpoints to get the number of lines of code added and deleted, and then count the total number. And if you'd like to learn more about how to do it, you can read our blog post where we cover this topic and describe all the ways to get this information using the REST API and a few Python scripts. So I'll share the link with you. So, and here is one more case that our customers use our app for, and it's exporting pull request data for audit and reporting to management. So using our app, the users are able to demonstrate compliance without having to take the time and resources away from the projects. For example, when a new version of software is released, using our exporting resources, you can easily get the statistics on what was actually done during the time spent developing this version. Then the statistics can be passed on to the management and stakeholders, or stored in some internal warehouse. And just to remind you of all the ways it's possible to export the data from Awesome Graphs to CSV, check out this blog post on this topic. So that's it for the main part. Thank you for staying with me until now, and we are coming back live for the Q&A part in a moment. So see you soon.